So this is our factoring. This is our factoring notes part 2. Today we're going to talk about factoring where a is 1, meaning we're going to factor here where a is 1, meaning x squared coefficient is 1. Okay? We're going to talk tomorrow about where a is not 1 or a is greater than 1. And there's a little bit more to it in that case, but we're going to talk about that. We're going to talk about some special products today. So you guys have all seen this before. We're going to do this together. We're going to talk about it. When a is 1, meaning right here, you guys still do the same process of a times c. What is 1 times 12?
12.
12. So I'm looking for factors of 12 that multiply to give me 12 and add to give me that number in the middle, 7. So it's 1 and 12, 2 and 6, 3 and 4. Now, you don't have to list out the factors. I heard, Raul, was that you?
Yeah.
Okay, good job. I heard that. You don't have to list out the factors. I'm going to for a couple of these just to kind of get our brains working. But you guys always have to check. You've got to check to make sure that your signs are correct. So when I factor this into two binomials, x goes in the front of each of them, and Raul told us 4 and 3. I totally agree with that. Positive 4 times positive 3, positive 12. Positive 4 plus positive 3, 7. So it's plus 3 plus 4. And you can always go back and check by doing what? How can we check this? Make sure we're right.
Foiling.
We can FOIL it, and when you do that and combine like terms, you will get your original problem. Okay? All right, so guys, same thing. We're going to go through the process. The first thing you would ask yourself is there a GCF? And there's not one. I have 3 terms.
Gabby Rodriguez isn't in class.
Okay, so now we're going to factor where a is 1. So I'm going to say, okay, 1 times negative 48 is negative 48. So what are the factors of negative 48 that multiply to give me negative 48, but add to give me negative 2?
Positive 6 and negative 8.
Correct. Positive. I have 8 and 6. So think about 8 and 6. I want a negative 48 when I multiply. That means one of them has to be negative, one of them has to be positive. But I want a negative 2 when I add. So negative 2 plus 6 gives me, negative 8 plus 6 gives me the negative 2. So there's your factored form. If you guys don't know that, you need to write out 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Write the factors out and see, okay, what's going to give me the result that I need? I need a negative 2. Can I somehow get a 2 from 8 and 6? Yes. Questions? Again, you can check by going back and foiling. All right, so here I have a is 1 here. So if I multiply 1 times negative 30, I get negative 30. What times what gives me a negative 30 when I multiply, but a negative 1 when I add? So 30 is 1 and 30, 2 and 15, 3 and 10, 5 and 6. How could I somehow combine and get a 1?
Positive 5 and negative 6.
Okay, so I would have y minus 6, y plus 5. Negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. Good to go. All right, so now we're going to say a is 1, so 1 times 30 is 30. What are the factors of 30 that multiply to give me 30 but add to give me 17? So I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. What would it be?
2 and 15.
2 and 15.
2 and 15.
Correct. So I have x plus 2, x plus 15, because I need a positive 30, so 2 times 15 is 30. And I need a positive 17 when I add, so 2 plus 15 is 17. Good. Hi, Gabby.
Hello.
I have no idea what was going on.
Yeah, that was really weird. I don't know. I didn't think you kicked.
All right, so let's just scoot, you guys. Generally, when a is 1, you guys are pretty good at this. The signs are the thing that kind of give you some trouble. So that's why we always need to make sure that we go back and we FOIL it out to make sure that we are correct. Again, a is 1 here. So 1 times negative 27 is negative 27. What are the factors of negative 27 that give me a positive 6 when I add? So I have 1 and 27, 3 and 9. How can I possibly get a 6?
-3 and +9.
Okay, so -3, +9. If you're not sure, guys, sit here for a second and go, okay, -3 times 9, -27. -3 plus 9, 6. We're good to go. You can FOIL it back out and make sure that you get this answer. If you FOIL it back out and don't get that answer, chances are you just did something wrong with your signs. All right, you see a big number, it doesn't matter. 1 times -50 is -50. So I need the factors of -50 that multiply to give me -50, but add to give me 23. So I have 2 and 25, 1 and 50, 2 and 25, 5 and 10. Anything else? How could I possibly get a 23, guys?
-25 and +2.
There we go. X minus 25, X plus 2. Check. -25 times 2 is -50. -25 plus 2, -23. We're good. FOIL it back out, and you'll get that same answer up there. Questions? How many of you kind of like factoring? Right, I understand. I understand.
Yeah.
Okay, tomorrow, guys, we're going to talk about this factoring where A is not 1. You see how the first number here is not 1? Okay, we're going to work on that tomorrow. But right now, we're going to talk about these special patterns. Difference of perfect squares. You guys are going to see that 100,000 times, all right? We're going to focus right here on difference of perfect squares and our perfect square trinomials, okay? Whoops. We're going to work on our difference of perfect squares and our perfect square trinomials. So when you have two terms, like you do here, do you guys see I have two terms? You have 4x squared and you have 25. The first thing that you should do when you have two terms is say, is this the difference of perfect squares? What does the word difference mean? Difference means what in math?
You subtract.
Subtract. Is there a subtraction sign in between here?
Yes.
Okay, so it is the difference. And are both of these perfect squares? Yes or no?
Yes.
Yes. Difference of perfect squares, you're going to have the same terms in your binomials, but you're going to have different signs, one positive and one negative. Doesn't matter where you put the positive or negative, but what are the two terms that I'm going to have here? What times what gives me 4?
2.
So I have 2 and 2. What times what gives me x squared? X and x, right? What times what gives me 25?
5.
5 and 5. So your binomial will have 2x in the front, 5 in the back, and your signs will be different. Do you see how that's a plus and that's a minus? Or it could be vice versa. But when you FOIL this back out, guys, with difference of perfect squares, the middle terms cancel out. The middle terms cancel out. Everybody see that? All right. This is the same thing. This is a minus sign, so that means you're going to have two binomials, 1 plus, 1 minus. If I have x plus y quantity squared, don't you agree that that means I have x plus y times x plus y, right? And then over here for z squared, I have z times z. So the only thing you have to do here is write x plus y at the front, x plus y at the front, and then z in the back. Our signs are different. There's your difference of perfect squares. That is going to happen when you have two terms, a minus sign in the middle, and both the terms that you're looking at are perfect squares. So let's look at these. You guys are going to get really good at these. First of all, look at the sign in the middle. Two terms, okay? There's no GCF or anything like that. I got two terms. What's the sign in the middle? What's the sign in the middle? Come on.
9x.
Okay, I have a minus in the middle. So what times what gives me 4x squared?
2x.
2x and 2x. What times what gives me 25?
Don't we already do this?
Yeah,
-5.
I rewrote the same problem, sorry. So in the front of each parenthesis, I have 2x. In the back of each parenthesis, I have a 5. And my signs in the middle are different. Doesn't matter where you put the plus, where you put the minus. Now, if I foiled this back out, right, let's just check this real quick. I have 2x plus 5, 2x minus 5. I suggest, guys, when you take your test on Tuesday, that you check this and foil it back out. 2x times 2x is 4x squared. 2x and 5 is negative 10x. 5 and 2x is plus 10x. 5 and negative 5 is 25, negative. What happens to positive 10x and negative 10x? They cancel out. Are we left with 4x squared minus 25? Yes, we are. So make sure that you guys take a second to check. We okay? All right, let's look at number 2. 2 terms. Is there a minus sign in the middle? Yes or no?
Yes.
Okay, so check. Are these perfect squares? What times what gives me y squared?
Y.
Y and y. What times what gives me 100?
10 and 10.
10 and 10. So my 2 parentheses are going to look exactly the same. Y in the front, 10 in the back, and then what are my signs?
Plus and negative.
Plus and minus. They're going to be different. It could be minus and plus. It doesn't matter, just as long as they are different. When you have the difference of perfect squares, it's 2 terms. Both those terms are perfect squares, and there's a minus sign in the middle. All right, what about here? Is there a minus sign in the middle?
Yeah.
Yes. Okay, so what times what is going to give me 9x squared?
3x and 3x.
3x and 3x. What times what is going to give me 81y squared?
9y.
9yn.
9y.
Okay, so my 2 parentheses are going to look like this. 3x in the front of both. What's in the back? 9y. And then what are my signs in the middle? What are my signs in the middle? Come on, guys.
Plus and minus.
Plus and minus. Good. Could I factor that a little bit more because they both have a 3 and a 9? Yes, but we're not going to worry about that right this second. All right, let's look at this one. Minus sign in the middle, 2 terms. Yes. What times what gives me 49y squared?
7y.
7y and 7y. What times what gives me 1?
1.
1 and 1. So my 2 parentheses are 7y in the front, 1 in the back. And what are the signs in the middle?
Plus and minus.
Plus and minus. It can be minus and plus. Does not matter. All right, how do we feel? You guys like different
Pretty good.
squares? Okay.
It's pretty simple.
Okay, good, good, good. All right, we're going to skip cubes for right now. We're going to go here to a perfect square trinomial. All right. This is different from what we just did because how many terms do you see?
3.
3.
3.
You don't have to recognize this pattern. You guys can factor this like normal. You can factor this like normal. If I say that A is 1, all right, let's factor this. 1 times 9, 9. What are the factors of 9 that multiply to give me 9 but add to give me 6?
3 and 3.
3 and 3. What are the signs?
Positive and negative. Positive?
Positive, positive, good. Because this is positive and this is positive. If you have the difference of perfect squares, your signs will be different, and when you FOIL it out, the middle term cancels out. When you have a perfect square trinomial, the signs are going to be the same inside, whether they're both positive or both negative. And when you FOIL it out, you do have a middle term. They do not cancel out. So you can write it either way. I prefer you write it the way that I have circled because that looks cooler. But if you don't, not a big deal. Now here, all right, here is you guys are going to be like, wait a second, how do I factor this one? Well, let's think about it. This is a trinomial, right? If you get something and you're like, I'm not really sure how to factor this, this is confusing to me, probably it's one of those perfect trinomials or something like that, perfect square trinomials where there's a pattern. Is 4x squared a perfect square?
Yes.
Yes, 2x and 2x, right?
Mm-hmm.
Is y squared a perfect square?
Yes.
Y and y. Now, if this was the difference of perfect squares, it would look like this. 4x squared minus y squared. And you guys would tell me 2x plus y, 2x minus y, because the middle terms would cancel out. But it's not. There is a middle term. That means both of your parentheses are going to be the same, just like this one. So you're going to have two parentheses, 2x and y, 2x and y, but your signs are going to be the same. Is it going to be plus plus or minus minus?
Minus minus.
Why do you know that, Kayla?
Because the middle term is negative.
Because the middle term is negative. If everything inside your problem is positive, then your signs are positive. But in this case, whenever you have a negative, you have to make sure that you account for a negative answer. So I would rewrite this as 2x minus y quantity squared. All right, that's just recognizing patterns. We're going to see more. Okay, so tonight for homework, you guys are going to work on some recognizing patterns of difference of perfect squares, perfect square trinomials, and you're going to factor where a is 1. Tomorrow we'll factor where a is not 1, where we have to do a little bit more work. That kind of tends to be the one that gives you guys the most trouble, but that's okay. We're going to work through it, and you guys will be fine.